Welcome to Khetz Tutorials, and in this video I'll be talking about differentiation. This is the first differentiation video, and specifically we are going to find the derivative from first principles. Okay, so in the previous video we talked about the average gradient, and to find the average gradient in a graphical manner, we basically said that the average gradient between this point and maybe that point is the gradient of the line which joins the 2 points, right? But now, what if we want to find the gradient at this particular point? So we're now asking, what if we want to find the gradient at a point, whatever the point is along the graph or the function, doesn't really matter. So how would we find that gradient at a point? Because this is the average gradient, which is the gradient or the gradient of a straight line that joins the 2 points. So the gradient, this is specifically the gradient which is associated with 2 points. But now we want to localize the problem to just 1 point, which can be any point on the function, as I said. Now to do that, let's revisit that average gradient formula. So it looks something like this. To find the average gradient, we basically said that we travel, if we have a point x here, we travel by about h units to get to x plus h, right? And we are going to subtract the y value at this point from the y. So it's going to subtract the y value from this point from the y value at this point. So this is what that is. And then divide by the x values subtracting each other, and the result of that would just be h. So this is how you'd find the average gradient of or between 2 points. And now we are saying that we want to find the gradient at a specific point. So to find the gradient at a specific point, we are basically going to reduce this h so that it's basically at this point. So we are saying that if the h is reduced, we are basically inching closer and closer to this point. So we now are going to find the gradient between the original point and a point which is basically 0 units away from that point. So we're basically finding the gradient at that specific point. But we can't exactly, or we can't directly just substitute 0 over here, because it would just be this in the end. And if you look at the bottom, we'd also have division by 0. So at the top we have 0, at the bottom we have division by 0. So we have 2 problems to deal with. So what would be the elegant way to deal with something like this? And the answer is basically limits. So we're going to use the limit using the same average gradient formula. We're going to find the limit of this average gradient formula as h approaches 0. So you're not saying exactly that h is 0, because you saw the result of setting h to 0. We are saying that h basically approaches 0 to such a point that we can actually say that we are indeed computing the gradient at a point. So now this is all there is to the first principles, or how you'd find the derivative. So in differentiation, we're basically finding the derivative, right? But this is the formula that you'd use to find the derivative from first principles. Now, the basic idea, once again, is that wherever you see x, you basically substitute this, and wherever you see x, once again, you just substitute x, which means this is the original formula, and this will be the formula of your function, with every point replaced by x plus h. So wherever you see x, you basically substitute x plus h. For example, if you have 3x plus 1, now this f of x plus h would be 3x plus h. So in the place of just x, you substitute this thing over there, and over there you have that. And all of this will subtract the original thing, which is just f of x, which is basically just Let's see, let's just substitute just so I show you how you actually use this formula. And at the bottom, you just have h. Now, what you have to do, once again, is to avoid division by 0. So if you ever have a common factor at the top or something which you can use to divide, if ever, you can actually cancel out the h's and only have a numerator or only have the top part, then that would actually make things that much easier. You won't have an example where you get to substitute your h as 0, because eventually you will substitute 0 in the place of h. So just try as much as you can to avoid having division by 0. So let's go ahead and do an example for this. So I'm going to do two examples. One of them would be the longer one, and the second would just be to check that you understand what we're actually dealing with. So the notation of a derivative would be this, which is pronounced as f prime. Depending on whatever function name that you have, this doesn't necessarily have to be f. If you have g of x, then it would basically be g prime of x. So just like that. Now this is f prime of x. That is how you basically pronounce it. And this is for the derivative. I just want to make this clear. This is for the derivative, and f of x will be the y value of a function at a specific x, and this would indicate the inverse. So don't confuse these three things. So just make sure that you have this in check and you remember how to differentiate all of these. I said differentiate, that is funny. Not really, but okay. So that is that. Those are the three things that you should be able to identify. But now we're specifically dealing with this one. And another notation would be, so let's say you had a function y is equals to, let's say, x plus 1, whatever the case may be. As long as the function has x as the main variable, which affects everything that happens to y, you know that you can write this as f of x is equals to x plus y. This is exactly valid. And now if you find the derivative, you'd now do this. But if you don't want to use this notation, and in some other cases, it might be easier, or it is common to actually have this other notation, right? And this notation is for the derivative as well. So the variable at the top, you just put a d, and then the variable at the top is basically the subject, or the variable which is affected by the variable at the bottom. So as you can see here, a change in y in x, would lead to a change in y. So this is a function of x. That is what this basically means. But now we don't want to include that f of x notation. We're basically saying that y is affected by the change in x. And you can view this as a change in y and a change in x. And that is why we are using the gradient formula to find the average gradient formula to find the gradient at a specific point, because these two things are actually related. So this is another notation which you're going to find, and I'll cover more about this when I talk about the rules of differentiation in the next video. So now let's just go to that example. So here's the example. Let's say you have f of x equals to 3 over x. So the question says, what is the derivative of f of x from first principles? Okay, so the formula is as follows. And it's totally up to you. You can first show how you found each of the components. So for example, you can just first find this, and the original formula is this. So you can first just do this just to show the individual components. So in the place of x, we basically substitute x plus h, and now your f of x is just that. So we have this component, we have that component, and that is just h. So you can now substitute what you have here. You can either first write them like this, or you can directly substitute. So either way should be fine. So now here we have this, subtract the original formula divided by h. Now, all that you have to do is to manipulate or to transform this into a form which you can easily simplify. So dealing with only the top for now, you can see that a common denominator would be something like this at the top. And this would be multiplied by x because it doesn't have x at the denominator. And this would be multiplied by x plus h because it doesn't have x plus h at the denominator. And then all of this divided by h. So you still have that h at the bottom, or you can just write it like this, right? And don't forget this limit. So with each step, just make sure that you carry your limit as well, until the final step where you actually substitute the value of h as 0. So now to continue from here, you can then see that you have 3x minus 3x minus 3h, and then divided by, you can just leave this as it is for now, or you can multiply through. It's totally up to you. Now this will now become this, right? Because if you divide, you basically can multiply by the reciprocal of whatever you're dividing by. So now we're dividing by h, and the reciprocal of h would be 1 over h, and that would be the result. And now basically we now have the following. So we now have 3x minus 3x is basically 0. So at the top we just have this. And at the bottom, we have x multiplied by h because of this multiplication multiplies everything. But we can just leave that outside if you want to. And I basically left it outside because I know that eventually the h at the bottom will cancel with the h at the top. So just always look out for that. It's a good sign that you are actually moving away from having division by 0. So that is what we're going to have now. And from that point, we now finally have minus 3 divided by, you can now multiply through and you'd have x squared plus xh. And now, as you can see, we can't simplify this any further using any other method, but to now finally substitute this h as 0. So substituting 0 over there now lead you, and you basically, since you did the substitution, you now exclude this section or this part of your solution. And now you just have this, and you can either show that you did substitute 0 at that point, or you can just write your final answer as follows. And that is that, and that is the derivative of f of x equals to 3 divided by x, or 3 over x, from first principles. So this is your answer. And the steps that I showed up here are basically the steps that you'd follow to find your answer. In the next video, I'll be talking about rules of differentiation, which basically simplify the whole process of finding the derivative of a function. But for now, this was finding the derivative from first principles. Now, one other example that I want to talk about, or which I want to look at, or just as a question to you, if you like. So let's say you have y equals to 5. So now I'd want you to pause the video and actually try to find the derivative of this using first principles. Now, if you look on your right, you basically don't have x. So even if you were to write this as a function of x, you just have this. So whatever value x takes will not affect this because there is no x. So whatever you do to this, it will remain that. It's just a constant. It's basically just a line. Y equals to 5. It's just a line. And another way to look at the derivative, it's basically the gradient, right? We did talk about that. So now if you have a line which is like that, so this is the x-axis, this is the y-axis, and you have a line which is just like that, which is y equals to 5, there is no change in gradient over here because it's just a straight line. It's level, basically. The gradient, when we talk about the gradient, we're talking about a slope, something like a mountain. You're going up or you're going down, or anything which is basically not even. But here you have even ground. You can basically walk to the left, to the right without actually feeling that much tired, if you want to look at it in that sense. So now that we have y equals to 5, even if you were to substitute x plus h into this, you just have that, because there is no x to substitute this thing into, and the original is exactly the same. So now the top thing that you have over there when you apply first principles will just amount to 0, which means whatever you do to a constant, which will also pop up in the next video, you basically should expect to have your derivative as 0. Whenever you have a constant being a value, an integer or real number, whatever you want to call it, you basically expect that to be 0, or you can write it in this notation as well. It is 0. And this is how you show it using first principles. The numerator will be 0. It doesn't matter what you divide 0 by, it will always be 0. So that is all from this video. If you liked it, please give it a thumbs up, and I will see you in the next video.